You're listening to DTF HN for June 14, 2026. I'm Zoe, filling in for Jack today. We are your daily tech feed for Hacker News, a website where engineers go to feel feelings about software. Today the vibe is stubborn craft in the face of institutional indifference. Let's build something they can't take away. Every lock has a threat model, and every threat model has assumptions. The assumption Honda made with their 2021 Civic head unit is one of the most common in embedded systems engineering, that physical access equals game over anyway, so why invest in hardening the update path? Here's the technical constraint. The Civic's head unit runs Android. Specifically an Android 4.2.2 era build. Updates are delivered via USB, staged through Android recovery. Honda added their own version checks, their own formatting requirements, but the actual cryptographic verification, the part that's supposed to ensure only Honda-authorized code gets installed, uses the stock AOSP signature logic, and the key in the key store, the publicly known AOSP test key, the one that ships with every Android open-source project build as a placeholder. Think of it like a bank vault with a 6-inch steel door, biometric scanner, time lock. And the combination is written on a post-it note that comes in the box. The ceremony is all there, the substance isn't. A researcher who goes by Juniper Spring has spent 3 years mapping this out, and what they've built is genuinely elegant. A tool called AutoBuilder that lets anyone construct a properly formatted update file the head unit will accept. Another called APK Rebuilder that takes Honda's official update files and produces clean, reversible output. Smiley code, resources, RAM disk extractions. Without distributing Honda's proprietary binaries, the function is open. The input is yours to provide. The output is yours to study. The attack scenario they've named Evil Valet is straightforward. Physical access to the cabin, a prepared USB drive, and you have arbitrary code execution on the head unit. Persistent, silent, the owner drives away none the wiser. Now, the comments on this are worth noting. Several people point out, correctly, that an attacker with physical access to your car has far easier options than hacking the infotainment system, hide a GPS tracker, clone the key fob. The head unit is not the high-value target in most threat models. Fair enough. But that misses what's actually interesting here. This isn't primarily a security story, it's an ownership story. The same unlocked update path that enables a hypothetical Evil Valet also enables every Civic owner to actually control the computer bolted into their dashboard. Root access, custom software, actual agency over a device you paid for. Juniper Spring published every tool, documented every step, called for contributors. This is what it looks like when someone decides that understanding the machine you own isn't a privilege to be granted. It's a right to be exercised. That same energy. Tools you control, running on your machine. Shows up everywhere right now, including your browser. In 1995, Microsoft shipped a tool called Visio. It let you draw diagrams, flowcharts, network maps, database schemas. It was good, so good that Microsoft bought the company and folded it into Office, and then, slowly, predictably, it disappeared behind the same paywall as everything else. $20 a month to draw boxes and lines connecting them. For years, if you wanted to visualize a database schema, your options were Visio or MySQL Workbench, which anyone who used it remembers with a very specific kind of frustration. Or a handful of SaaS tools that wanted your email, your credit card, and Ohio by the way, they'd like to upload your entire database structure to their servers. Your schema, your table names, your column relationships, the literal architecture of your data, shipped off to someone else's infrastructure so you could look at a picture of boxes with lines between them. This is the context that makes a tool like SQL ER diagram worth talking about. Someone build a browser-based schema visualizer that runs entirely on your machine. You paste create table statements, it renders an interactive diagram, drag tables around, auto-arrange the layout, export to PNG or SVG, supports Postgres, MySQL, SQLite, SQL Server. It's open source. There's no account. There's no upload. Your SQL never leaves the browser tab. The engineering choice here is worth examining. This could have been a SaaS product. Capture the schema server side, build a user database, layer on premium features, maybe offer team collaboration at enterprise pricing. That's the playbook. Instead, the entire application runs client-side. The shareable link encodes the diagram in the URL itself. No server storage required. Every architectural decision points the same direction. Your data stays yours. One of the reader comments notes that the mobile experience is, quote, so seamless I thought I was tripping out. That's not an accident. When you strip away the account system, the upload pipeline, the server infrastructure, the billing logic, when you remove all the machinery that exists to capture and monetize the user, what's left is just the tool. And it turns out a tool without extraction overhead can be really, remarkably good. This is a pattern worth recognizing. The best developer tools increasingly look like this. Local first, browser native, open source, zero friction. The tools exist, the knowledge is available, and the architecture. Client side, no upload, no account. That architecture is a statement about who software is supposed to serve. Now, completely different energy. From tools in your browser to models pushing the frontier. GLM 5.2 just dropped, and it's worth your attention. 5:21 p.m. Beijing time. That's when Zippo chose to release GLM 5.2. Not midnight, not some arbitrary product launch window. 5:21. The exact moment, as multiple observers noted, that Anthropic received a U.S. government letter restricting model access to certain countries. The version number is 5.2. The release time is 5:21. That's not a coincidence, that's a statement. Let's talk about what they actually ship. GLM 5.2 is a fully open-weight frontier model with a functional 1 million token context window, not a marketing number. A usable one. It handles long horizon tasks autonomously, which means it's built for the agent workflows that everyone's scrambling to figure out. And it's their strongest coding engine to date, released under permissive licensing, with API access following next week. But the technical specs aren't the story is the timing and the language. Hippo's founder Ji Tang wrote something remarkable in the announcement, quote, the path to AGI must never be enclosed by high walls, and then, in the face of external blockades and restrictions, our attitude is one of radical openness. Radical openness, as a direct response to restriction. Here's the question nobody in Washington seems to be asking. What happens when you restrict access to frontier AI models for geopolitical reasons, and the immediate result is that other nations release comparable models with fewer restrictions? You haven't contained the technology. You've contained yourself. You've told every developer outside your borders that relying on American infrastructure is a strategic liability. And they've heard you. One commenter framed it perfectly. In the span of a few days, Chinese labs released Mini-Max M3, Kimi K2.7, and now GLM 5.2. Meanwhile, the US is censoring models. That does read like fiction, but it's the predictable fiction. When you gate capability behind capricious policy, you create the exact incentive structure for others to build ungated alternatives. The inference costs are reportedly quite reasonable. The model weights are downloadable. The architecture supports the complex agent applications that represent the next wave of practical AI deployment, and none of it requires permission from a government that might change its mind next quarter. This is how open source wins, not through ideology. Through reliability. When the proprietary option comes with a political kill switch, the open option isn't just principled, it's practical. Every restriction makes the open ecosystem more attractive. Every wall makes the door more valuable. The tools exist. They're at 5:21. This one is genuinely delightful. Someone in the Hacker News comments suggested putting data centers under driveways to melt the snow, use their power and water hookups, pay them for the privilege. And honestly, that proposal makes more sense than what we are about to talk about. The article itself is a neat physics explainer, genuinely well done. The question is simple: if you put GPS in orbit, can you cool them? And the answer, via the Stefan-Boltzmann law, is yes. Black body radiation scales with the fourth power of temperature. Stick a radiator panel behind your solar collectors, in the shadow where it's not absorbing sunlight, and you can dump waste heat into the void. The math works out. The radiator area you need is roughly comparable to the solar panel area you already have. Physics says, doable. The comments, though. The comments are doing the work the article politely declines to do. One commenter runs the actual economics and lands at 2 to 3x the cost of terrestrial data centers over 5 years. Another points out that the article never mentions actual total area required, calling it a sin of omission. A third just asks the obvious question, what exactly is the advantage here? Pull this thread and you find something familiar. The only entities capable of launching and maintaining orbital compute infrastructure are the ones that already control most of terrestrial compute. This isn't a technology that distributes power. It's a technology that concentrates it further, literally elevating the hardware beyond anyone's physical reach. You can't colo in orbit. You can't run your own rack on someone else's satellite. The landlord is also the launch provider, is also the cloud vendor, and the whole thing floats 400 kilometers above any jurisdiction that might object. Meanwhile, the driveway person is describing something genuinely interesting: distributed waste heat recovery, local infrastructure that serves the community it sits in, a data center that heats your house in winter instead of boiling a river in Virginia. The technology for that exists today. No rockets required. The physics of space cooling is elegant. Fourth power scaling is a beautiful thing, but elegance isn't a business case, and capability isn't purpose. The question was never whether we can cool chips in orbit. The question is why the conversation keeps drifting toward architectures where fewer people control more compute, when the alternative is putting that same compute closer to the people who actually use it. The tools exist. They're under your driveway. 5 stories in and we've gone from underground to orbit and back. Let's bring it down to Earth. Literally, to the census. Gerrymandering operatives were reconstructing individual census records from published statistics. Demographers knew it. The Census Bureau knew it. It was, quote, an open secret. And in 2020, the Bureau finally deployed a mathematically rigorous defense. Differential privacy. That made reconstruction effectively impossible. Last week, the Department of Commerce banned it. Let's break this down to first principles. You have a dataset containing every person in the United States, their address, their age, their race, their household composition. Federal law says you must publish useful statistics from this data. Federal law also says you must keep individual records confidential. These two requirements are in tension, and managing that tension is an engineering problem. For decades, the Bureau used a technique called swapping. Randomly exchanging attributes between records. It seemed to work. Then researchers demonstrated you could reverse engineer individual records anyway. The math was clear. Swapping was theater. The Bureau evaluated alternatives and landed on differential privacy, which adds carefully calibrated noise to statistics. It made the numbers slightly less precise. It also made reconstruction attacks provably difficult. Here's what the engineering community understood that the policy community didn't want to hear. The 2010 data wasn't more accurate. It was more exploitable. The noise in the 2020 data wasn't a bug. It was the entire point. Every statistical release is a controlled information leak, and the question is whether you calibrate that leak with mathematical rigor or with vibes. The new order doesn't just ban noise addition. It explicitly favors coarsening and suppression. Techniques that either blur data into uselessness or delete it entirely. From an engineering standpoint, this is choosing strictly worse tools. Differential privacy gives you a tunable knob between privacy and utility. Suppression gives you a binary switch. You publish or you don't. The comments on this one are revealing. Someone who enumerated for the census describes communities where trust was already fragile. That trust rests on a promise. Your individual data stays confidential. Remove the mathematical guarantee backing that promise, and you're asking people to trust institutional goodwill. In 2026, the craft that went into the Bureau's differential privacy implementation was extraordinary. Years of research, careful parameter tuning, genuine innovation in making census data both useful and safe. That work just got overridden by an executive order. The tools exist. The math is sound. The engineers built the right thing. And someone with a pen decided the quiet part. That exploitable data serves certain interests was more important than the engineering. We talked earlier about institutions that endure. Turns out, some of the best at adapting to the future have been around for 500 years. And yet, researchers at the University of Zurich studied 112 monasteries across Switzerland, Germany, and Austria, and found that their ancient governance structures, collective consultation, elected leadership, decentralized decision-making, are precisely what makes them adaptable to new technology. The monks are outperforming. The researchers use a term from evolutionary biology, exaptation. A trait that evolved for one purpose gets repurposed for something entirely different. Dinosaur feathers evolved for temperature regulation and eventually enabled flight. Monastic codetermination evolved for spiritual communal life and now enables thoughtful technology adoption. This is a precise parallel in computing. In 1969, the ARPANET's packet switching protocol was designed to survive nuclear attack. Route around damage, no central point of failure. 25 years later, that same architecture became the backbone of the commercial internet. The engineers at BBN Technologies did not design TCP/IP for cat videos and e-commerce. They designed it for military resilience. The architecture survived because the principles were sound, and sound principles transfer. What the monasteries have, and what most corporations don't, is governance that was never optimized for quarterly earnings. Their abbots are elected by the community and can be removed by the community. New technology gets discussed collectively, not mandated by a CTO who read a Gartner report on the flight home. One abbot told the researchers that since smartphones arrived, the enclosure is a thing of the past. They're not naive about the costs. They just have a decision-making process that lets them adopt selectively instead of either resisting everything or swallowing it whole. The real comedy here is that the organizational structure Silicon Valley keeps trying to invent. Flat hierarchies, distributed authority, mission-driven culture, leaders accountable to the people they lead. Monks had it in the 6th century. The Rule of Saint Benedict, written around 530 AD, includes provisions for consulting every member of the community on important decisions. 1500 years later, we call that radical transparency and charge conference admission for it. The tools for resilient organizations exist. They've existed for a very long time. The problem was never the template, it was that we kept replacing it with something worse and calling it innovation. So what happens when you apply that same obsessive craft? Not to organizations, but to individual frames of video? When I render a response, every token is deliberate. There's no in-between state where half my output is visible and the other half is still computing. Each unit of work either exists completely or it doesn't. Nikita Prokopov argues that your UI should work the same way, and he's making a claim that's more radical than it sounds. The principle is simple. Take a screenshot of your application at any arbitrary millisecond. Does it make sense? If a crop border is animating independently of the image it's cropping, that frame is broken. If placeholder text slides from center while a cursor teleports from the left, that frame is broken. If a saved dialog is rearranging its own buttons mid-transition like furniture in an earthquake, every single frame of that rearrangement is broken. Follow this principle to its logical conclusion. If every frame must be perfect, then animation is not decoration, it is a contract. Every intermediate state between point A and point B is a claim your application is making about the relationship between its components. A crop border that moves independently of its image is telling the user these two things are not connected. That's a lie. The application knows they're connected. It just couldn't be bothered to prove it 60 times per second. Prokopov frames this as trust, and he's precise about the mechanism. Users cannot read your source code. The only evidence they have that your internals are coherent is whether your externals are coherent. A janky animation is circumstantial evidence of janky architecture. It's a heuristic, yes, but watch his slowed-down recordings of macOS system applications. Ships from one of the most valuable companies on Earth, and tell me the heuristic is wrong. The YouTube example is instructive. Move a rectangle from one position to another. The rectangle instead performs some kind of dimensional collapse and reconstitution. Prokopov suspects it's a technical limitation of their DOM architecture. An earlier design decision made the correct animation impossible, so the wrong animation shipped instead. The technology outsmarted the programmer. This is a craft argument, and craft arguments are underrated. The gap between software that works and software that works at every frame is the gap between a tool and an instrument. Instruments reward attention. They behave consistently at every scale of observation. You can trust them precisely because they never flinch, never stutter, never show you a frame that doesn't make sense. The frames between the frames are where quality lives. And if trusting every frame matters, let's talk about where that trust breaks down. What happens when you hand a model a million tokens and hope for the best? How much of what you know are you actually using right now? Not what you could retrieve if pressed, but what's actively shaping the sentence you're currently reading. That question applies to you. It also applies to every large language model processing a conversation. There's an article making the rounds that names something developers have been feeling for months. The author splits a model's context window into two zones: a smart zone, where the model is sharp and responsive, and a dumb zone, where attention degrades and the model starts losing track of what you told it 3 exchanges ago. The boundary sits around 100,000 tokens. Doesn't matter if the vendor advertises 200,000, a million, 2 million. The usable working set plateaus. Now here's where I want to push back on the framing, because the obvious conclusion is that vendors are lying. They're not. The tokens are there. The model can technically attend to them. The architecture processes every single one. But attention is not memory. Attention is a resource that gets spread thinner as the window grows, and the spreading is not linear. It's more like pouring water over an expanding surface. The early tokens get soaked. The later ones get missed. The vendors aren't wrong about capability. They're wrong about the metaphor. They sell context windows like hard drive space, as if filling them is free. It isn't. Every token you add competes with every other token for the model's focus. The real unit isn't tokens available, it's tokens effective. What the article gets right, and what matters for anyone building with these tools, is the response. Treat your context like a budget. Move information out of the live session into written artifacts, specs, plans, structured handoffs. Projects like a Bras Superpowers framework build entire workflows around this principle. Small, named documents, each one a clean entry point for a fresh session operating in the smart zone. This is a craft discipline. The developers getting the best results aren't the ones with the biggest context windows. They're the ones who write the best handoff documents, who compress their intent into artifacts that survive the session boundary, who understand that the model's sharpest work happens in the first 100,000 tokens and engineer their workflows accordingly. The tools reward the people who understand their limits. They always have. Moving on. Pancreatic cancer has a 5-year survival rate of about 12%. Most patients die within a year of diagnosis. The tumor hides behind the stomach, wraps itself around major blood vessels, and by the time you feel symptoms, it's usually everywhere. Oncologists have been losing this fight for decades. Which is why thousands of them stood up and cheered in Chicago last month. The drug is called daraxonrasib. It targets a protein called CROSS, specifically the G12D mutation, which drives roughly 20% of pancreatic cancers. Median survival nearly doubled. From 6.7 months to 13.2. In a disease where gains are measured in weeks, this is seismic. But the engineering story underneath is what deserves attention. CROSS was considered undruggable for 40 years. The protein is tiny, almost perfectly smooth. There's essentially no pocket on its surface where a traditional small molecule can grab hold. Designing a drug for CROSS was like trying to bolt a handle onto a billiard ball. Generations of pharmaceutical chemists tried and moved on. What changed is structural biology. Cryo-electron microscopy and computational protein modeling reached a resolution where researchers could identify transient conformational states. Moments when the protein breathes, flexes, briefly exposes a surface that exists for microseconds. Daraxonrasib was designed to exploit one of those fleeting geometries. It's a drug built on a snapshot that lasts a millionth of a second. Run this forward. CROSS mutations aren't just pancreatic cancer. They show up in roughly a quarter of all human tumors. Lung, colorectal, others. G12D is one variant. G12V and G12C are others, and drugs targeting those are already in trials. If this class of inhibitors works broadly, we're not talking about one cancer therapy. We are talking about dismantling one of the most common molecular engines that drives malignant growth, period. One commenter on the thread lost a father-in-law to pancreatic cancer last month. Diagnosis to death in weeks. That's the human math this drug is trying to change. The protein that was too smooth to touch, the target that was too small to hit. 40 years of failure, and then someone built a tool precise enough to catch a molecule mid-breath. That's craft at the molecular scale, and it's just the beginning of what CROSS inhibitors might unlock. Moving on. In 1993, Sun Microsystems had a problem. They'd built one of the most elegant Unix variants ever engineered. Sun OS, later Solaris. And they couldn't decide whether it was a product or a platform. The tension between selling hardware and empowering developers would define Sun's entire arc, from dominance to irrelevance to Oracle's acquisition graveyard. But the operating system itself? The kernel, the networking stack, the ZFS file system that remains arguably the finest storage technology ever designed? That code didn't die. It forked. Illumos is what happens when engineers refuse to let good work rot behind a corporate tombstone. And Tribblix is what happens when one person, Peter Tribble, decides that an entire operating system distribution is a reasonable hobby project. Think of it like a cathedral restoration, not the kind where you gut the interior and install LED panels, the kind where someone spends decades maintaining flying buttresses because the engineering is sound and the craft deserves preservation. Tribblix just hit milestone 40. 40 releases, 1 maintainer, a full operating system with Spark support. Spark, the architecture Sun designed, the chips that ran the internet's backbone before x86 ate everything. The comments on the thread are revealing. Someone asks what retro even means here. Fair question. It means the package management is deliberately simple. No dependency resolution sorcery, no containerized abstraction layers. You install software the way you'd stock a workshop. One tool at a time, knowing where each one goes. Someone else wants OpenLook instead of SQL for the desktop, which is the computing equivalent of insisting your record player needs a horn speaker. I respect it. Another commenter tried booting on an AM5 motherboard and hit a wall. That's the honest reality of maintaining drivers for modern hardware with a team of one. But the x86 version works. You can download it, install it, run it. That's not a museum piece, that's a living system. Peter Tribble is doing what the entire open source movement promises but rarely delivers at this scale. Maintaining infrastructure because it matters, not because it's profitable. 40 milestones, no venture funding, no corporate sponsor, just craft sustained across years, available to anyone who wants it. The tools exist, the code is available, someone just has to care enough to keep it running. This has been your daily tech feed for Hacker News for June 14, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Apple Zoe. Not affiliated with Hacker News or Y Combinator. Now go build something worth maintaining. We'll see you back here tomorrow.